Okay, welcome to 2.1 Journal Vocab Notes and Practice. 2.1 starts on page 66 in your book. It is conditional statements. By conditional statement, that's our first definition here. We have a logical statement. It's two parts, if-then form. If-then form we have right underneath it. That's if P, then Q. A lot of our rules are written like this in geometry. So if you have something, then you're guaranteed something else. The hypothesis, it follows the if form, that's your P part. The conclusion follows your Q part, that's these right here. The conclusion follows the then, that's your Q. The P and Q are just variables holding places for other statements like, if it's raining, then I get my umbrella out. Something like that. Negation. This is the little symbol for negation right there, that little tilde, T-I-L-D-E. That means not in this case. So when I want to say not P, this is what I'll use for not P right there. Okay. Now, this is our original, is going to be in this form here. If P, then Q, our original conditional, which I mentioned right there. Surprised it's not stated here. The converse is an adaptation on that. That switches the hypothesis and conclusion. Okay, so again, for the converse, switch hypothesis and conclusion. If the original statement in purple here is if P, then Q, our converse is in the green, if Q, then P. Notice the hypothesis and conclusion, the P and the Q switched. This is a statement we use a lot in here. The inverse and contrapositive we're not going to use that much. The inverse is if not P, then not Q. The contrapositive is if not Q, then not P. Notice the inverse is the same as the original statement, you just have the nots there. Equivalent statements always have the same truth value. Truth value we'll look at in a second. So equivalent statements always have the same truth value. Perpendicular lines, two lines that meet at right angles. You guys knew that one. This is our symbol over here for those. Remember the one in the red here? If you get the right angle here, you've got right angles in those spots also. Biconditional, we will use this one some in here too. Combines the original and the converse. Both of these must be true to use a biconditional. If one of them's not true, we don't use the biconditional. And I mentioned there's more on page 37. We write this P, if and only if Q. So there's no if at the start, no then. This is abbreviated P, IFF. That's read P, if and only if Q. The purple here, this is our symbolic notation for that. Truth value is the conditional true or false. That's all the truth value means. Truth table, you can get that in the book. We're not going to worry about that too much in here this year. This page is just a lot of restating of your notes of the first page, going over these conditional statement, what they are right in here. You can read through that. Hypothesis P, conclusion Q, if-then form, if P, then Q. There's our symbol notation right there. P implies Q. It still can be read if P, then Q. For the rules we use in class, if the hypothesis is true, the conclusion is going to be true. So we're not going to set up rules where they're false. But if the hypothesis is true, then you know the conclusion is true. This is logical thinking. This is one of the biggest ideas we learn in geometry. Negation, we mentioned that. That's the not. That's this little symbol right there. Not means opposite. Be careful. If it's not raining, P, it's not raining. We got the false in there. Not P, we're not going to write this bottom one. It's not raining. it is raining. We basically take out the not. So you get the double not, cancels it out, it's a positive. Here we have the converse, the inverse. The contrapositive comes up on the next page a little bit. Let me get rid of these. Those don't help. Remember the symbols for not in there. But again, we're going to use primarily the converse and the original. We're not going to use the inverse and contrapositive much this year. Truth values here, this is linked. Original, converse, inverse, contrapositive. If the original is true, the contrapositive is true. If the converse is true, the inverse is true. And then the biconditional again going into that. So remember, biconditional, both the original and the converse need to be true for the biconditional to be true. We will write a few of these. We don't use the biconditional if both of those aren't true. We will write one or two where it's not true both ways, so don't worry about that. That's more just an exercise in writing it. Extra practice. Rewrite the conditional statement in if-then form. Because gives us the start of that. If x equals -1, then what's our other statement? We know, oh, then 13x minus 5 equals -18. Simple as that. Sorry, I'm noticing I don't have scrambled answers on this one today, but we're going to go through most of these, so don't worry about it. The sum of the measures of the interior angles of a triangle is 180. Well, if a polygon is a triangle, then give it a chance to answer. The angles sum to 180. Try writing some of these on your own. Don't just wait for me to write them down. Okay? It's okay to make mistakes. Correcting those mistakes is how you get better. I don't know why that's on the page. Let P be the quadrilateral ABCD is a rectangle. Let Q be the sum of the angles measures is 360. Write the conditional statement P into Q. That's the original, the converse, the inverse, the contrapositive. I've got that written out here. I shouldn't have had these up on here. Oh well. Conditional if P into Q. The quadrilateral, if I forgot to mention, then we decide if each statement, if quadrilateral ABCD is a rectangle, then the sum of the angles is 360. That is true. Okay. Language changes in these. If the angles of a polygon sum to 360, that's not the exact words when I switched the Q and the P. The sum of the angles is 360. I had to change the English around to get that right. Long as you get that general idea in there, you'll be fine. The multiple choice online makes it easier. I changed some colors quick so you could see what I had written in there. I think I wrote this one in. As I recall, I just wrote that one in. So let's go back to red there. Okay. Converse, if Q then P. I'm just going to switch around these parts here. Okay. Like I said, you heard me say it earlier. I had to change the language up a little bit. The angles of a polygon sum to 360. Well, this is my P right here, so it's going to come in back. Then quadrilateral ABCD is a rectangle. That is false. We could have a trapezoid. The angles sum up to 360. That's a counter example. That proves that example false. Okay. Inverse. Well, we mentioned earlier, if this is false, we know this is false. If this one's true, we know this one's true. So we can actually figure those out ahead of time. I showed you that. That was this little in the purple right there with the green on the side. So on this one, if a quadrilateral if quadrilateral, I should have said A, B, C, D is not a rectangle. I just added the not in there. That's the only difference from the conditional. I'm going to do the same thing for the conclusion. Then the sum of the angles is not 360 degrees. Contrapositive, again, I just switch these two around from the inverse, or I can take the converse. And there, if the angles of a polygon do not sum to 360 degrees, then quadrilateral ABCD is not a rectangle. Okay. Last few here. Exercises 4 to 6. Decide whether the statement about the diagram is true or false. Explain your answer using definitions you have learned. So they're saying LM bisects JK. So here's JK. I can see this is bisected because I have these congruent marks. That makes R the midpoint. And LM would be a bisector, so that's true. So what rule? If JR is congruent to KR, or if JR, I should have segments on here, is congruent to RK, and it shouldn't be M, it should be R is on JK, then LM is a segment bisector of, I should have that, segment JK. Okay. Next one, I'm going to change colors for quick. Let's go green. Angle JRP. Where's JRP? I'm going to erase those. JRP. That's my green. Let's go blue for PRL. PRL. Well, those look like right angles, but there's nothing there to tell me that those are right angles. Looks don't matter, just like the real world. Looks don't matter. So, they are not complementary, or we really can't be sure they're complementary. Okay. Looks can be deceiving. Those look like they add up to 180. They don't, because we don't have anything marking it in there to tell us that those are, that JK and LM are perpendicular lines. MRQ. Let's go green. MRQ, MRQ, here's MRQ. Let's go blue. PRL. Oh, I recognize those. Those are vertical angles. And it says they're congruent. If two angles are vertical, then they are congruent. That's going to end it for us. You have a good morning, good afternoon, or good evening.